And the orange. I'm going to get rid of this. So vectors, you can go pretty far with vectors. I'm only going to be giving you the basics of vectors and how to add and subtract them. But you can think of vectors as, you remember my analogy before that if you have somebody and they give you a present, but they decide, I'm going to put the present in another box. And then I'm going to put that present in another box. Remember this?
Oh, those people.
Right? Hi.
I might have a question for you, but I can wait till you're done.
Oh, I just started my lesson, so let me pause it. And so we're going on the senior trip. We're trying to find subs, but I'm one of the chaperones for it. So
I'll babysit.
I won't. I'll be at Disneyland. All right, we're back. We're already live. We're already live. We're already live. All right. And it's true. Hold up. Bring it back. Bring it back. Bring it back. So, like I said, it's like a box inside of a box inside of a box. Vectors are kind of like that. All a vector is the distance formula. It's the distance between, say if I was, let me get rid of this. Say if I was down in Midtown, and here's J and K, right? Here's, let's go, that's 15, that's 16. So this is the Memorial Auditorium. I don't know if you know that. But if I was, J, K, what's before J, H, I, J, K, great. Just kidding. If I'm standing here, right? Actually,
Right by the highway. Just kidding.
just kidding. K, J, I, H. If I'm standing right here at K and 15, right? How many blocks would it take for me to walk over to get to this point over here? How many blocks would it take? 3. You would go over 1, up 2, right? Now, if I had a drone that could pick me up and bring me over to that spot, that would be called the vector. Okay? If a drone picks me up and brings me over to here, then my vector direction counts. The vector is going up and to the right. And really, all a vector is the distance formula. We know the change in x. The change in x is 1. We know the change in y. The change in y is 2. So we're going to use our distance formula for finding the vector. Finding what's called the magnitude of the vector. Just the distance between the points. Okay. Before we start with that, though, this is almost looking at the second box. Let's look even a little bit closer. Because I could label this as a point, and have to figure out the magnitude from the x and the y's given by each of the points. Just like the distance formula, right? It's almost identical to the distance formula because if this is the point, let's see, if this is 11, 15, and I'm going to, let's see, actually that would be the other way around. If this is 15, 11, and I'm going to, let's see, 14, 16, again, backwards. Again, wrong. Back. 9. If I was going between those 2 points, right, I would just have to, if I was a distance formula and I was working this out, I'd say that's x1, that's y1. That's x2, that's y2. And to find the distance, I would use this exact formula, right? I'd use that same formula. We know this from a squared plus b squared equals c squared. This is just a triangle. And we could figure out the a and the b to find our c, our hypotenuse. The c value is going to be our magnitude. Okay. Now, the reason this is useful is if I was flying a plane this way, but the wind's blowing me this way, where am I going to actually end up? Am I going to end up over here? No. Am I going to end up probably like way down here? No. I'm going to end up where? It matters on how fast I'm going in the wind, right? But my vector is going to change because there's 2 factors going on. There's 2 factors. Okay. This comes in when we have to add and subtract vectors. So I'm a little bit sorry for you saying that. I just want to show you how these work, why we'll do them. Okay. If I am going on a boat, but I'm going upstream, the stream's going this way. If I'm on a boat going upstream at 40 knots and the water's going downstream at 20 knots, someone standing on the side of the river is going to see what?
20
Right? 20 knots going that way. We have 40 knots going the other way. So it's going to look as though I'm moving actually 20 knots. You see? When you get to physics, this is all about forces, direction, normal force. You're going to get into elasticity coefficients. So talking about how much it stretches, how much it rebounds, all that is quantifiable. And we have to use vectors because forces are going to go in different directions. The normal force is, the force that keeps you from falling through the ground. It's the ground pushing you up. Right? If you're in quicksand, the normal force is too light, so what do? Sink. Right? So we have to know what each of these forces are. Vectors just allow us to look at the different forces involved all at once. Okay, so let's see where we are. I want to actually go ahead and write this as my vector that I'm going to call this is z vector. Guess why? With vectors, you have to put these brackets instead of, it's not an ordered pair. It's not an ordered pair. It is with the brackets instead. You know you deal with vectors if you see brackets. I kind of think of this kind of looks like a V just kind of flipped over, right? So vectors use those kind of V brackets. But looking at this, remember that the vector is just a change in x and the change in y, those two values. So my a value is the change in x, my b value is the change in y. So what do we have for a z vector going, being lifted up on my drone and going all the way to that one? What is my a value? What's my b value? 3. Because the x change is +1, the y change is +2. Now, if I was starting here, this is just a scenario, it's a different kind of problem, just like a slight change and see if you get it. If I was starting up here and I was flying down here, what would my change in x be in that case? -1. Direction matters. And then going down this way would be -2. Okay? And actually, the magnitude would be the same for each of those because we're going to square those values, right? But it does matter, the direction does matter as far as knowing which way you're going. So this is, the questions will actually ask you, what is the magnitude? What is the magnitude? And which direction? So this would be down to the left. Our original problem, which everything here is based on, is up and to the right. Okay. The reason we don't use quadrants or say that is because magnitude, there can be two vectors with identical magnitudes, and it would just be as though we're going up 3 over 2. Or we start from this point, we go up 3 over 2. So it should be parallel because if the vectors have the same magnitude, then we know that we end up with lines that are going to go in the same direction. Okay. So here is the basic vector. From there you can find the magnitude. If you go back a step back from this, you're finding the change in the x and the change in the y to figure out what the vector is going to be. I already mentioned here, direction counts. If I'm going between point A and point B, but from B to A, it's BA. From A to B is AB. Very important with that, right? Because if you're measuring the normal force versus gravity, and say you forget which way the forces are going, you could end up with the problem where you're like floating into air. Right? We got to make sure that we have our vertexes correct. That's all. Scalars, constants without associated direction. This is just, honestly, it's synonymous, not synonymous, kind of synonymous. It's similar. It's the same as, it's congruent to 3 times x. X is my variable in this case, it's just 3 times that, right? So if I ended up with, say, I want you to jot this in the notes, I didn't add it. If I have a vector, the vector z, that is 2, 4, and I do the constant of 3 times z, then all I need to do is 3 times 2, 3 times 4. 6, 12. That's all there is to it. When you got a scalar, you're basically just looking at your A and B value and you're multiplying it by that same multiple. Okay? And that will change your magnitude. So your magnitude is going to change. I want you to start to notice in what factor does it change. Does it, having 3 vector z, change the magnitude by 3 or 9 or what? Okay, so just notice when you're doing the homework, it's just like a little bit to kind of catch on to, start to see those patterns. All right, displacement vectors representing a distance traveled. That's everything I've been showing you. Velocity vectors, this is where you'll do this in physics. And like we did with the boat on the river, we have 2 different vectors going in different directions, so we would need to consider both directions. Okay, so that is the basics of vectors. The only other thing I want to play with here, actually before I do this, let's figure out the magnitude of my drone flight here. So I know that my vector z is 1, 2. So I want you to please find the magnitude of z. Go ahead and find the magnitude of z. And based on what information you know, you either choose this one or this one. It's just, this is a bit more expanded to see what A and B are, but if you know them, you don't need to plug in your x1, y1 and all that. You can do it right here. So go ahead and figure that one out. Basically, I'm going to take my A, square it, plus B. And again, the magnitude, again, is just how far I'm going to fly to get to that other block, because I'm not walking on the streets. I'm flying. Okay, it's equal to root what? This is 1 squared, it's 1. 2 squared is 4. 1 plus 4, 5. So we know that it's going to be root 5. All right, that's easy. Everyone okay with finding the magnitude? Okay. Is everybody feeling thumbs up, sideways, down if you were given 2 points? Maybe I'll just do this one. Let's do this one. All right, here we go. First off, we have the point 1, 2, -2, -2. Okay. And then we have the point 1, 2, 3, 4, and 1. Let's say that we're going between those 2 points. And we're going to call this, I want you to find this, if we call it A and B, then AB is equal to, let's go with, let's call it M, is vector M. Okay. Now I want you to find, first off, find vector M, the A and the B values. Remember, we're talking about changing X, changing Y. So I want you to find first what vector M is, and then I want you to find what the magnitude of it is. So we're starting from the point. Remember that what goes in here between A and B are the change in X and the change in Y. And then from there we know our A and B, we take the next step. So this is like the tiniest box, and then around that is our next box, and then the biggest box on the outside. So we're starting from the very middle, somehow. So not sure where to start. Let's start by figure out you're changing the X. Changing the X, side to side, horizontal. Changing Y, vertical. It also depends on the direction of the vector, and it's going from A to B. So both of those are going to end up being positive. If we're going the other direction, both will be negative. All right, so for those that are still working, keep working. If you're not working yet, I want to engage you for a moment. What is my change in the x? How far over do I go with my x's? From -2? 4. 6. How far of a change do I have in my y's? I go from -2 to 1? 3. Change in y is 3. So then I come over here. I know my change in x. Vector m is equal to an a value of 6, b value of 3. Okay. Now we know a and b. Now we can find the magnitude. So now I'm going to go ahead and throw those in there. 6 squared plus 3 squared. 36 plus 9, 45. We can even make that into something fun. 9 times 5. What can I take out? 9. 9 comes out. We square root 9, we get 3 root 5. Okay, raise your hand if you got those two answers. Good. All right, it's most folks. Good, good. All right, the very last bit, the last step we have to figure here is just knowing how to add these things together. And that's where it's going to come in handy. It's going to be really helpful when you get over to physics. It's going to be helpful. So basically here we have two vectors. We have vector A, vector B. We're given the A and B values for them. And you know what? I'm seeing now that it doesn't matter. It's fine. So vector A, vector B. If I'm adding my vectors A and B, all I have to do is add together. Oh, I see why. I want you to correct something right here, please. Let's go ahead and do this. We are going to call these, instead of x1, y1, we're going to call it A1 and B1, A2 and B2. Change that. And let's make it so we can actually not have A, B, A, B, A, B, A, B. We'll make this B. We'll make that W. So the line below, we just have to change that. I know it's a pain. This can be easier. Add the A's. Add the B's. The same will apply down here. We'll keep the same vectors. We'll just change it. B minus W. All right, so double check. Make sure that you have everything changed what I just changed. So all we have to do with this, just like when we had a scalar and we multiplied it in, we almost distributed it to the two A and B values. Here, all we have to do is define B plus W vector. I just have to add together the two A values. Add together the two A values. Add together the two B values. Once you've done that, you get your sum of them. You get your sum of the two vectors. So I changed the names of these. I call them VW now. Instead of X, Y, I make it AB, AB, and then I just change the rest of it. So this is a situation where if we have the water going this way, and that's equal to, let's say it's going in a diagonal here on a map. And let's say that's going at 4, 4. Now, if I have a boat going this way on the river, I'm going this way on the river, and this is W, and that's equal to negative 5, negative 6. I want you to go ahead and do the addition of these two things. What am I going to do with my A values? I don't know. What am I going to do with my B's? I don't know. So this is the situation on a map. The river goes up and to the right. The boat's going down at a certain vector. We have our two vector values, which show the change in the x and the change in the y's. So let's see, what are we going to get for this? We're going to add together our a's. Negative 5 plus 4. Negative 1. We're going to add together 4 and negative 6. Negative 2. So you can see that combine these two vectors, the river is pretty strong. The river is pretty strong, but the boat has a stronger magnitude. So thus, it's still going down to the left, right? Not quite as fast, but it is going down and to the left. So I'd say this vector is -1, -2, and it goes down to the left. You're going to have to describe where it's going. Up to the right, up to the left, down to the right, down to the left. 2 options. Okay. All right. That concludes vectors for today. I think this gives you a pretty good foundation for when you see it again next year. You'll probably have a whole month on vectors in different applications. Okay. So thumbs up, sideways, down for vectors. I know it's probably around here. Yeah, okay. I see a lot of ups and side ups. Okay. All right. Subscribe, please. Please subscribe.